Ba da do, yada do, yada do, yada do. Ba da bo da do do, do 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 do. A community is a group of interacting species. The types of interactions can vary over all the possible combinations. The first type of interaction you can have are mutualisms that are beneficial to both species. This might be like termites and their gut microbes. The microbes help the termite get nutrients from the cellulose in wood, and the microbes have a termite working on finding food and providing a healthy environment. Another interaction is competition, which is negative to both species, such as an oak and a neighboring pine tree. Both are trying to get sunlight, and the presence of one species shades the other, reducing the amount of sunlight both receive. The third type of interaction is exploitation, where the interaction is positive for one species and detrimental to the other. Examples of this include predation, like lions eating zebras, zebras eating grass, as well as a microbe infecting a lion and using the lion's cellular mechanisms and energy for its own reproduction. Sometimes one of the species is unaffected by the other's presence. For example, the interaction could be positive for one species and have no effect on the other. This is called commensalism. Barnacles on whales are thought to be a commensalist relationship, because the barnacle gets free transportation to new locations, but the small size of the barnacle doesn't seem to have much of an effect on the whale. Alternatively, the interaction could be negative for one species and have no effect on the other, called amensalism. An example of this might be toxins that are produced by black walnut that reduces competition by other tree species. The toxins can inadvertently affect grasses and other small plants that occur beneath the tree, even if the grass has no effect on the black walnut. These interactions can lead to some interesting population dynamics of the different species in the community. The most famous example is of the lynx and the hare, where years of trapping data showed two populations oscillating in a similar pattern. The predator lynx population tracked the population of its hare prey. As population of hares increased, the lynx population would soon follow, and as the hare population decreased, so did the lynx. Equations by Lotka and Volterra offer a hypothesis for these fluctuations. In the equation for the prey population, prey increases based on its reproductive rate, but can be decreased by the number of predators killing them and the rate of predation. And in the predator population equation, the predators increase based on their ability to change prey biomass into their own offspring. When predators reduce the number of prey, they reduce the biomass available for their future offspring. From these equations, you can get stable cycling of the two populations. It's interesting to note that if you remove time as an axis, you can see that the general relationship between the two populations is cyclic.